Okay, so let's go 15 divided by 0.2. So first thing we did just now, we made both, we made the decimal number an integer, but we have another method where we have to consider the fraction bit, just to be sure that our answers are correct. Just when you're in doubt, you just want to double check, okay? So every whole number in the world is always over 1. So you know 15 over 1 is the same thing as 15, yes? Okay, so this is divided by, could you please change 0.2 into a fraction for me? Good. So divided by 2 over 10. All right. So this now, you are dividing two fractions. And there is an acronym we normally use to help us divide fractions. So when you're dividing fractions, please, you can use what we call, I don't know if you've heard about it before, KFC, which is keep the first fraction the way it is, flip the second one, and change that divide to times. So you end up with 150 over 2, which is the same thing as 150 divided by 2, which is 75. So you can clearly see, if you're in doubt, just use the other method, which is this method, to see if that would help. Another question I'm going to go into is this bit here. You want to first of all know if it is in 1 decimal place or 2 decimal places or 3 decimal places and so on. This particular number here has 1 decimal place. So I'm going to put 1 decimal place here. And why is it 1 decimal place? Because this number here is the only number after that point there. So it's 1 decimal place. So when it's 1 decimal place, whatever you have there would be over 1 0 at the bottom, and put your 1 there, which is 10. If I want to write it as a mixed number, it will be big 3, 8 over 10. What sort of fraction is this called, Grace? What sort of fraction is this one called? Just tell me on sure. Okay, yes. So this is a mixed number from that decimal number we've just written. And this, if you convert it into an improper fraction, will give you this. So 10 lots of 3 is 30. Add 8, you get 38 over that 10. Okay, so 1 decimal place, 1 0. Okay, divided by. Now, what will this be as a fraction, please? Good, 8 over 1,000. So, in order to make sure we are seeing exactly what we're doing without making everything mixed up, I'm going to change the color of this pen to green, and I'm going to take a new slide and repeat that question here. 3.8 divided by 0.008. We want to double check our answer. We have used the first method, but we want to double check our answer now. Then divided by 8 over 1,000. How do you divide two fractions? Remember the KFC I told you. You keep the first fraction as it is, you flip the second one, and you change that divide to times. Now you can multiply the two fractions, which is you multiply the top. Yeah, I've seen your keep, change, flip. Yeah, that's fine. So you multiply the top and you multiply the bottom. Okay, now we can knock off the zeros. Why? When we knock off the zeros, it means we're saying that 10 can actually be used to divide the top and the bottom. Okay, so if I say how many lots of 10 in 80, you're going to tell me 8, won't you? And how many lots of 10 in 38,000, you're going to tell me 3,800. So basically, the knocking off of the zero means you are dividing by 10. If I knock off 2 zeros, if there was another 0 here, I'm dividing both the denominator and numerator by 100. But I'm just crossing off 1 zeros top and bottom, means I have divided both top and bottom by 10. Now we are left with the long division or the short division, whichever you want to use. So let's go for the short division, because we had done the long division before. So how many lots of 8 in 38? There are 4 lots. Remember, you said that yourself. And that remained the 6. You put it next to that 0 there. How many lots of 8 in 60? We said 7 remained the 4. We put that 4 there. And how many lots of 8 in 40? We have 5. So you can see we got the same answer. So Using both ways, you should be pretty okay with it. I'm going to give you another example here. Look out for the use of fractions when you are multiplying decimals, but more especially when dividing decimals. Colin R. Davis' quote says, "The road to success and the road to failure are almost exactly the same." Doing maths using short-term targets and repeat to retain strategies are the most recommended bite sizes, which align well with the secrets of maths success. According to John D. Rockefeller Jr., the secret of success is to do the common thing uncommonly well. So, if you're looking for a great teacher with many years of experience in the UK maths curriculum that can help you or your child get on the right path to success in maths, sign up now for yourself or your child and get ready for a boost in your maths confidence for that pass grade you deserve in GCSE maths exams. Click on the link below or description box below and see you on the inside of our tutoring sessions.